A general approach to a nonlinear system, or even a linear system, whichever system you're talking about, is to isolate one variable in terms of the other and then set that variable equal. Because basically to find a solution, you need to find a coordinate that's going to work, right? Solution means graphically an intersection point, right? If you have a curve and you have a line, for example, this is a nonlinear system, these would be the solutions, right? The intersection points. So each of them are responsible for a coordinate x comma y, right? A coordinate point, x coordinate and the y coordinate, right? The coordinates of the meeting point. So if you solve for one variable in terms of the other, then you can work from there, right? So what I mean is, in this case, we're going to solve for x squared. So x squared plus 4y squared is equal to 24. And then what you want to do, you want to subtract 4y squared like that, so that x squared is by itself. So x squared as a result is equal to 24 minus 4y squared. The second equation, you want to do the same thing and isolate your x squared by adding 4y on both sides like that. This isolates x squared, so you get 4y. Okay, so now what you want to do, notice that when we're talking about a meeting point means they have the same x and y point, right? These two equations will have the same coordinates, x and y coordinates. So that means whenever any of these coordinates is squared, it's also going to be valid, right? Because any point x, any coordinate x for this point, for example, if it's squared, it's going to be the same result, right? Because suppose that x is 0. You square that, you still get 0. When you square 1, for example, if this meeting point had an x coordinate of 1, 1 squared is still 1, right? So if you set x squared in terms of everything else for these two respective equations, you can set x squared being equal as well. Okay, that's still going to work. So when you set x squared being equal of the first and the second equation, what that leads to is the substitution. The right sides can be set equal as well. So 24 minus 4y squared can be set equal to 4y, the respective right sides. So now notice what this does. This actually creates a quadratic equation for the variable y, right? If we add 4y squared on both sides and subtract 24 on both sides, right? So subtract 24 and add 4y squared. This is what you're going to get. You're going to get a quadratic in standard form. This will give you 0 on the left side as you want it, and 4y squared plus 4y minus 24. Okay? And this is great. This is what we wanted. Now you want to divide both sides of the equation by 4, right? So you want to divide everything by 4, because these numbers can be divisible by 4. So the result is going to be y squared plus y minus 6 is equal to 0. Okay, and I just switched sides so that I want the 0 to be on the right side, just to make it look better, to make it look more standard. All right. So now realize that you can factor this now. You can factor the left side as y plus 3 times y minus 2 is equal to 0. Because factors of negative 6 are 3 and negative 2. When they multiply, they give you negative 6. When they're added, 3 and minus 2, 3 plus minus 2 is the same thing as 3 minus 2, which is giving you plus 1, right? The coefficient for the y. Okay, so this is the rule for factoring this. So now that means we can set each one of these factors to 0 and then solve for y, right? So y plus 3 is equal to 0, or y minus 2 is equal to 0, right? Subtracting 3 on both sides solves for the y value of negative 3, and in this case y value is going to be 2. All right, now notice that here you will have also not just real solutions but also imaginary solutions. And why do I say that? I say that because you can use this equation. This equation would be far easier to find your x values than this one, because there's a 24 hanging in there and there's also minus there, right? So this one would be easier. So plug your y's into this. So in the first case, look what happens. Let's start with the real solutions. I'm going to plug the positive y value. X squared is equal to 4 times the 2, right? Which is 8, right? X squared is equal to 8. So x squared is equal to 8. Squaring both sides gives you plus minus radical 8, or plus minus 2 square root 2, right? Because 4 times 2, square root of 4 is outside. It gives you 2. Right? Take the square root of 4 out, you get 2, and you get only radical 2 inside left, so you get plus minus 2 radical 2. So this is the real solution, right? So the real solutions will be so 2 radical 2, and the y tested was 2, right? So 2. And then the other one is minus 2 radical 2 and also 2. Now speaking of the imaginary solutions, so I'm going to put imaginary solutions. Now imaginary solutions, there will be 2 of them as well. So we're going to test now the negative 3 for this equation. So x squared is equal to 4 times negative 3, which gives you x squared is equal to negative 12. Now notice you can't square root it using real numbers because you can't square root the negative. But when you're talking imaginary numbers, you can, right? So you're talking about this. And notice that this means x is equal to plus minus radical 12 times square root of negative 1. Right? So what that tells you is that square root of negative 1, recall that the square root of negative 1 is I, speaking of the imaginary number symbols. Right? So this turns to I. And 12 can be written as 4 times 3 inside the radical, so it's going to be 2 radical 3 essentially, right? Because the square root of 4, just like in this case, was taken out. So x would be equal to plus minus 2i radical 3, right? Because there's a square root of negative 1, we bring it in the front of the radical, so we get I, right? So plus minus 2i radical 3. So these are your 2 imaginary solutions. So now, how do we write that? We write that, so when 2i radical 3, the y value tested was negative 3, right? So it's minus 3. And the second pair is minus, right? There are 2 imaginary solutions, minus 2i radical 3. And also the same y value, right? Minus 3 that we tested. Right? So these are your respective answers, the real solutions and imaginary solutions. Thank you so much for watching. Hope this was helpful. See you in the next video.